Imagine a world where all your fundamental beliefs about the universe were instantly shattered. A world where the foundations of physics will be questioned and our understanding of the universe will be turned upside down. This is not a scene from a science fiction movie, but the reality that scientists face when researching the incredible discoveries of the James Webb Space Telescope. Dr. Michio Kaku recently said we may need to rewrite the textbooks on the beginning of the universe. The announcement follows the release of a groundbreaking image from the James Webb Space Telescope. This image highlights unusual processes in the universe that challenge our current scientific understanding. Since the launch of the telescope, not only have previous theories about the origin of the universe been challenged, but our ideas about exoplanets and physics have also been completely disproved. What is the new situation, and what response can scientists give to this new provocation? We are currently experiencing a complete upheaval of the old scientific rules. The James Webb Space Telescope is sweeping away our old ideas about the universe, and every image presented by this wonder of space exploration is a success. James Webb, the telescope's namesake, would be very proud. Webb led NASA for a long time, although he himself was not a scientist but came from a business background. Webb knows how important space exploration is to all humanity. In the 1960s, Webb strongly promoted space travel, launching the Apollo program and advocating for space probes. Today, scientists are amazed at what the telescope named after this pioneer in space exploration can do. The images are so clear and sharp that they take our breath away. For the first time, we have at our fingertips comprehensive analyses of exoplanets, some thousands of light years away. Webb tirelessly shows the scientific community that it has relied too long on its old discoveries and ideas. At first, many scientists also experienced a sense of uncertainty and insecurity. Everything they believed in could now be wrong. Michio Kaku, a famous American astrophysicist, is among those who are optimistic about the new developments. Kaku has long acknowledged that our previous theories were inadequate. The fact that we have never succeeded in unifying the world of subatomic quantum particles with the world of matter suggests that we do not understand the fundamental processes of the universe well enough. Now, exoplanets also break the laws of physics. It is crazy. At first, it was just galaxies that were so old that they did not fit into our picture of the universe. Then there are the black holes and the giant structures that existed more than 13 billion years ago, when the universe was thought to be in its infancy. Today, even with planets, nothing is the same. The latest images from the James Webb Space Telescope show us a host of exoplanets that are shaking up our ideas about planets. James Webb has re-examined some of the strangest exoplanets known using his keen eye and unique spectroscopic arsenal. These instruments break down even the smallest light signal into individual components and analyze traces of elements, gases, traces of water, and parameters that allow conclusions to be drawn about the size and orbit of distant planets. Along the way, Webb has discovered more and more anomalies, extremes, and crazy planets. One notable example of an impossible world that defies the laws of physics is KLT 9b, an ultra-hot Neptune orbiting its star so close that its surface temperature is high enough to split water molecules into atomic hydrogen. Its proximity to its star has also resulted in what scientists call an atmospheric explosion. The planet and its atmosphere are literally being carried away by the star. The discovery is unique among all known planetary atmospheres, and for that reason alone, the planet poses a challenge. Webb found so many exceptions and extremes that it was impossible to count them. This planet is so strange that it is almost impossible to classify, and it is a particularly glaring and inexplicable exception to all the rules we humans have created. Let's take a look at one world that has scientists terrified. WASP 76b, a giant exoplanet with iron falling from the sky on its night side. The planet orbits its star in a concentric orbit, so it has one side that is extremely hot and one side that is extremely cold. The metals that melt and vaporize during the day condense into iron in a global cycle on the far side of the planet, then rain down on the ground. Once again, scientists are faced with extreme conditions that dramatically demonstrate the physical processes of exoplanets and raise more questions than they answer. The discovery of planets orbiting their star in the opposite direction to other planets in the same system is particularly intriguing and puzzling. Such a discovery forces astronomers to rethink theories about the dynamics of planetary systems and the forces that determine their orbits. WASP 17b is an example of such a crazy world. The planet was discovered as part of the Wide-Angle Search for Planets, or WASP for short. The exoplanet is a gas giant that looks a bit like our own Jupiter but orbits its star in a retrograde orbit, meaning that its orbital direction is opposite to the direction the star rotates. Until now, this was considered scientifically impossible. According to current theories of planet formation, all planets in a system should orbit their star in the same direction as they evolved from the original protoplanetary disk. One theory to explain such orbits is that gravitational perturbations from nearby stars or other large planets in the system can significantly alter a planet's orbit after it forms. Another possibility is that the gravitational dance between several large planets can pull one or more of them into a retrograde orbit. When looking for crazy planets, we don't have to look beyond the borders of our solar system. In the Kuiper Belt, we find the dwarf planet 2007 or 10, which scans show is unusually dark and red. Scans with the Webb spectrometer show that the planet is likely rich in complex organic compounds, which scientists call tholins. Despite its size and characteristics, 2007 or 10 has yet to be officially named because the planet's exact orbit is still unknown. Its possible composition, organics that are ultimately the basis for life, and unusual color don't match the images of other dwarf planets in the Kuiper Belt. Where did this planet come from? How did it form? And why is it so difficult to observe? Because of its great distance, observing 2007 or 10 accurately and for a long time is extremely difficult, even with our best telescopes. 2007 or 10 is likely the third largest dwarf planet after Pluto and Eris. Researchers consider it an important object for understanding the dynamics of the Kuiper Belt and the evolution of the entire solar system. Could there be planets without stars? Do you believe that there are planets without stars? Planets do form from the dust and gas left behind when stars are born, and then they remain gravitationally bound to their star, or so one might think. However, rogue planets show that this is not always the case. These planets are lonely planets in the universe, without stars, drifting freely in space. But where do they come from, and how do they survive the harsh cold of space? Rogue planets can form in a number of different ways. One of the most common ways they form is through ejection from their home star system. This can happen through dynamic interactions with other planets or passing stars where the gravitational pull is strong enough to tear the planets from their orbits. Another possibility is that they form as isolated objects in star-forming regions, similar to stars but lacking enough mass to initiate nuclear fusion. This could also explain the existence of objects like Jupiter. Jupiters are objects with a mass similar to Jupiter. As their name suggests, they are similar in size and mass to Jupiter, which itself is considered a destroyed star. Jupiter, the largest planet in the solar system, would need a bit more mass to initiate nuclear fusion itself. However, it lacks the necessary mass and thus becomes a planet. James Webb once again shocked the scientific community when his telescope discovered 80 such rogue planets, similar to Jupiter, in the Orion Nebula. The most bizarre thing about this discovery is the incredible fact that these 80 Jupiter-like planets form 40 binary systems. That means there are no fewer than 40 pairs of rogue planets orbiting each other in a relatively small space within the Orion Nebula. This is bizarre and scientifically impossible. Of course, the mere existence of so many Jupiter-like planets could be due to the fact that the Orion Nebula is one of the most active star-forming regions known to us. However, further detailed study later revealed that these planets are not planets at all, but rather lie somewhere between planets and brown dwarfs in terms of mass. This, of course, suggests that these are protostellar objects, since brown dwarfs are some of the smallest stars we know of. But what processes in the Orion Nebula are responsible for the formation of protostellar objects that behave a bit like planets, free-floating in binary systems across the cosmos? The mechanism behind this once again poses an extreme challenge to our scientists. This is probably a class of object in its own right, and the discovery once again pushes the limits of our astrophysics. It is possible that such massive free-floating objects are much more common in the cosmos than we thought. They may be normal, but they are not normal to us because we did not know about them before. It has been a long time since we have been able to detect exoplanets in the depths of space.